Good morning, everybody. Today, I can calculate normal distribution probabilities using second VARs, normal CDF. This type of question is a really simple, straightforward question to get correct. It is a very commonly asked Regents question as long as you know what to do. So, let's do it. The heights of women in the United States are normally distributed. When I see normally distributed, we're going to use normal CDF. So how do I do that? I go to my calculator. I hit second VARs. So second VARs, the VARs button is right below the down arrow. It's next to the clear button. You'll see this come up, and then option 2 is normal CDF. You'll see lower, upper, mu, and sigma. So let's talk about what these things mean first. So we have lower, put it up here. Lower, upper, mu, and sigma. So mu and sigma are Greek letters, and mu is a variable for the mean, and sigma is a variable for the standard deviation. The lower and the upper are the bounds. It'll tell you what to be between. Now, there's going to be a couple of little twists, and we'll fill those in when we get to them. But basically, for now, mu is the mean, and standard deviation is sigma. So I'm going to write lower, upper, mu, sigma. It says that the mean is 64, so mu is 64. It says that the standard deviation is 2.75, so sigma is 2.75. It's asking for the percent of women whose heights are between 64 and 69.5. That's your lower and your upper. So now I just pop those values into the calculator. 64, 69.5. Something's not right there. I don't know why I wrote mu's. Nope, never mind, that's right. Mu is 64 as well, and sigma is 2.75. Enter. I hit enter on paste. I hit enter again. Now, it's going to always give you a decimal. There are 3 circumstances. So for your normal CDF procedure, we hit second VARs, normal CDF. We enter the information, and get a decimal. Now from here, there's going to be 3 circumstances. Let's call this A. If asked for probability, you're done. There's no additional step that you have to do. If asked for percent, well, this goes back to 7th grade. If you want to turn something into a percent, then you multiply by 100. And if asked for, I'm going to say number of data points, multiply by total number of data points. So the notes that I put in front of the packet might look slightly different. I'm just kind of going off the top of my head here. But these are the 3 circumstances. If they just ask you for the probability, you're done. If they're asking you for a percent, you're going to multiply that decimal by 100. If they're asking you for the number of data points, I just wrote number of data. If they ask you for the number of data points, so for example, how many students, how many tests, how many whatever the question is talking about, you're going to multiply that decimal by the total number of data points. And you'll see what that means as we go through. So if you want to take a picture of this, again, you should have something similar to this in the front of your packet. Those are the three circumstances. So in this one, it's asking for the percent. So because it's asking you for a percent, so we got this 0.477 ... We're going to multiply it by 100. And to the nearest percent, that would be 48%. If it just asks for a probability, then you could just leave it as that 0.477 decimal, and you would see something like that in your multiple choice answer. And if it asks for the number of data points, you would multiply that decimal by the total number of data points. The lifespan of a 60 watts light bulb produced by a company is normally distributed. When you see normally distributed, normal CDF. That is the big understanding that you need to have. This is a relatively easy question to do computationally. It's just a matter of knowing to do normal CDF when you see normally distributed. So I'm going to hit second vars. Again, it's right next to the down button. Option 2, normal CDF. It says that it wants it between 1440 and 1465. So 1440 and 1465 are my lower and my upper. It says that my mean is 1450. And it says that my standard deviation is 8.5. So let's kind of get that information on the screen. Lower, upper, mu sigma. Again, my lower, my upper is the range that it's looking between. So 1440 and 1465. Mu is the mean, which is 1450. Sigma is the standard deviation, which is 8.5. So I popped that into the calculator. I get a decimal. And now there's three circumstances. If they're asking me for a probability, I'm done. If they're asking me for a percent, multiply by 100. If they're asking me for the number of data points, multiply by the number of data points. In this one, it's just asking for the probability. So I'm done. It's 0.8415. And your answer is choice 3. So if it's just asking for a probability, not asking for a number of data points, or not asking for a percent, you're done. All right, 2 twists on number 3. There are 440 students. Let's do a new color. Green sounds good. There are 440 students at Thomas Paine High School enrolled in U.S. history. On the April report card, the students' grades are approximately normally distributed. When you see normally distributed, normal CDF. Lower, upper, mu, sigma. With a mean of 79 and a standard deviation of 7. Students who earn a grade of less than or equal to 64.9 must attend summer school. Less than or equal to 64.9. So I need to know what my lower and my upper is from that. If it's less than or equal to 64.9, that means the highest, the upper, must be 64.9. What's the lowest? Well, 0. So if you see less than, If less than, the lower is 0. Whenever you see less than, the lower bound is going to be 0. So from here, I'm going to pop those values into the calculator. Second vars, option 2. Lower is 0, upper is 64.9, mu is 79, sigma is 7. Enter, and I get 0.021 ... Now there's 3 circumstances. If they ask me for a probability, I'm done. If they ask me for a percent, I multiply by 100. If they ask me for number of data points, multiply by total number of data points. It's asking me for the number of students, the number of data points, the number of students in this case. So I need to multiply by the total number of students. What's the total number of students? 440. So if they're asking me for a quantity for the total number of data points, in this case number of students, I'm going to multiply it by 440. The number of students who must attend summer school for U.S. history is closest to, well, 9.67 is really close to 10. So again, you're always starting the same way with your normal CDF. You're putting in your lower, your upper, your mu, your sigma. You're getting a decimal. Once you have that decimal, if it asks for a percent, multiply by 100. If it asks for the number of students or the number of data points, I multiply by the total number of students. And if it just asks for a probability, then you are just leaving it and you're done. We talked about less than. If we see less than, then the lower is 0. And we're going to see greater than or more than in this example right now. So I want you to read through it. I want you to kind of start. Actually, no, it's not much to start. I see normally distributed. I do want to go through it together. So I do normal CDF. Lower, upper, mu, sigma. So we've got a mean of 14, so mu is 14. We've got a standard deviation of 3.2, so sigma is 3.2. Now there's 2 questions. The first question, if a student is randomly selected, what is the probability that they spent less than 5 hours studying? Less than 5 hours studying. I want you to take about 10 seconds and fill in your lower and your upper based on less than 5 hours. If it's less than 5 hours, then your upper is 5, your lower is 0. Later on the problem, it says to round to the nearest 10th of a percent, so let's pop it in. In fact, I'm going to give you a little bit of a head start. I'll give you like a 15-second head start. Pop that information in, round your answer to the nearest 10th of a percent. Then there's a second question. Okay, second vars, option 2, 0, 5, 14, 3.2, 0.002, ... It wants it to the nearest 10th of a percent. So because it wants it as a percent, I'm going to multiply by 100. And I get 0.2%. Now there's a second question. So again, I'm going to do normal CDF. I'm going to do lower, upper, mu, sigma. I don't know why. Let's get this power. My script L did not work out very nicely there. So my mu and my sigma are not changing. The mean is still 14 and the sigma is still 3.2. And now it wants more than 22. So I want you to think about what it means this thing is more than 22. If it's more than 22, that means that the lowest it could possibly be is 32. Technically, it's 22.00000001, but whatever. 22 is sufficient. So if it's more than 22, that means my lower is 22. My upper, well, it can go on forever. So here's what I want you to do. Do you have a favorite number? If you have a favorite number, well, I'm going to use 9s. But if you have a favorite number, you're going to use your favorite number. I'm going to use 9, and I'm going to write 9, 9, 9, 9, 9, 9, 9, 9, 9, as many 9s as I can fit. Basically, a ridiculous number that this will never, ever get close to. Because when I'm going less than something, I can cut it off at 0. There is no cutoff as I go up to infinity. I can't put infinity into the calculator, so I'm going to put some really, really big number in there. If you like the number 7, you want to do 7, go for it. If you like the number 3, 3, 3, 3, 3, 3, 3, 3. But it's just got to be some ridiculously large number that's never going to hit. All right, no one's going to ever study for 99,999,999 hours in a week. There are not that many hours in a week, so it's impossible. So I go back to second vars, normal CDF. My lower is 22. My upper is 9 and 9, 9, 9, 9, 9, 9, 9. And my mu and sigma remain the same. And I get 0.006 ... And again, because this particular problem wants it as a percent, I'm multiplying it by 100. And the answer is 0.6%. So when you see less than, the lower is 0. If you see more than or greater than, the upper is 9999999999999, or whatever giant number that you want to put in. So let's just do a couple more. There's nothing new for me to teach you. We're supposed to go through a couple more. Again, every single Regents asks a question on this. This might be one of the easiest questions to get correct on the Regents. So if it's practiced, if you know what to do when you see normal distribution, you go to normal CDF, you know how to get there. It's really not a difficult lesson. All right. I want you to try star 5 on your own. It says normally distributed, so do your normal CDF. Lower, upper, mu, sigma. Pause it, try this problem on your own, and then unpause it. Okay, now that you tried it on your own, it says the mean is 76.2. That's mu. And again, mu, it kind of looks like an M and it kind of looks like a U. So I guess that's why they call it mu. Sigma, the standard deviation, is 4.7. Between a 70 and an 80, so my lower is 70, my upper is 80. Second distribution, normal CDF, 70, 80, 76.2, 4.7. I get 0.697, ... Now there's 3 circumstances. If they ask me for a probability, I'm done. For a percent, multiply by 100. For number of data points or a quantity, multiply by the total number of data points or the total quantity. So it's asking for how many students. It's asking for the number of data points. It's asking for a quantity. So I'm multiplying by the total number of students, which is 248. It's not asking for a percent. It's not just asking for a probability. It's asking for a quantity, the number of data points, the number of students. So I'm multiplying by the total number of students times 248. Approximately how many students is that's kind of implying it wants it to the nearest whole number, which is 173. I'm thinking one more. Yep, this is a good example because there are two separate questions within the question. So I'll just kind of give you that as a hint. So please pause, try number 6 on your own, and then unpause. And if you can get this question correct, then you're good. So again, pause, try number 6 on your own. As a hint, there are two separate questions within number 6, and then unpause. All right, let's see if you've mastered normal distribution. The number of hours of sleep employees at a company get per night is normally distributed. So when I see normally distributed, normal CDF. Lower, upper, mu, sigma. Mean is 7.1. Standard deviation is 1.4. What is the probability they sleep between 5 and 8 hours each night? So my lower is 5, my upper is 8, and it wants the answer as a percent. So, second vars, option 2, lower is 5, upper is 8, mu is 7.1, sigma is 1.4. I get 0.673 ... Again, 3 circumstances. If it just asks for a probability, I'm done. If it wants a percent, multiply by 100. If it wants a quantity or number of data points, I multiply by the total quantity or number of data points. This question wants the nearest percent, so I'm multiplying it by 100 times 100. When I hit times, it just takes the previous answer and it multiplies it by 100 in case you're wondering. The nearest percent, that's 67%. Now, as a separate second question, if there are 2,500 employees at the company, so it's a new question, so it's a new normal CDF. Now, the situation didn't change, so the mu and the sigma are the same, but now my lower and my upper are going to change. So mu is still 7.1, sigma is still 1.4. Approximately how many of them got less than 5 hours? Well, less than, the lower is 0. The lower is 0, the upper is 5. And again, don't worry, like less than or equal to or less than, it's not going to really make a difference for this type of question. So I go second vars, option 2, lower is 0, upper is 5, mu is 7.1, I already have that in there, sigma is 1.4, I get my decimal of 0.066 ... So if it asks for a probability, I'm done. If it asks for a percent, I multiply by 100. If it asks for the number of data points or the quantity, I multiply by the total quantity or total number of data points. It's asking how many of them, how many people. It's asking for a quantity. It's asking for the number of data points. So I'm multiplying by the total number of data points, which is 2,500. Times 2,500. To the nearest person, 167 people. That's it, my friends. It's a pretty straightforward lesson as long as you know what to do. It's all in the calculator. It's just knowing what to input, know how to deal with less than or greater than. If it's less than, then the lower is 0, and the number that it's less than is the upper. If it's more than, then the upper is 9999999, and the lower is whatever it was more than. Mu represents the mean. It will always be given to you. Sigma represents the standard deviation. That will always be given to you. Your classwork/homework is to finish this. Again, a very, very commonly asked question on the Algebra 2 Regents. Again, one more thing to sum up. There's 3 circumstances once you get your decimal. If it asks for a probability, you're done. For a percent, multiply by 100. For the number of data points or quantity, multiply it by the total number of data points or the total quantity. Have a great day, everybody.